This video is going to be about a new Python type called tuples, which are very similar to lists in some ways. But there's also an important difference, which is that tuples have a property called immutability, while lists are mutable. And in the second part of the video, we're going to discover what mutable and immutable mean. So let's begin with how to define tuples. As I say, they are very similar to lists. They represent sequences of data, but you create them using round brackets instead of the square brackets that you use to create lists. So you can create the tuple containing 1 and 2 and 3 using round brackets 1, 2, 3, as you see there. Let's have a go at doing this. So in this code cell at the top here, we're going to create a tuple called mytuple, and it's going to contain the elements 1, 2, and 3. And we just use round brackets to do this like that. An empty tuple can be created with an open round bracket and then a closed round bracket like this, just like we create an empty list with an open square bracket and then a closed square bracket. And finally, there is one perhaps slightly unusual piece of notation for creating a tuple with one element. So if you create a list with one element, like if you want a list just containing the number 1, you just do open square brackets 1, close square brackets. But if you did that with round brackets, it would look like using brackets as punctuation or like a function application. So when we create tuples with one thing in, we have to use round brackets and then a comma after the thing. Okay. So tuples, like lists, don't just have to consist of numbers. So as an example here, our tuple containing one thing had a string in it, and it doesn't have to consist just of things of the same type. So this right here would be a perfectly legitimate tuple with 3 elements. It's fine to have elements of different types in your tuples. There are many functions in Python for working with tuples, and those are in general very similar to the functions that you use for working with lists. Like for example, if you want to get a particular element from a tuple you've created, you can do that using the same square bracket notation that you use for getting elements from lists. So if we have my tuple like this, actually it wasn't 1, 2, 3, was it? It had hello in the middle. If we want the 0th element, so the element at position 0, we can just use square brackets notation like this, and that will give us back 1 as our element. If we want the length of a tuple, then just like for the length of a string or the length of a list, you can use the function len or len, and my tuple has 3 elements, so this output will be 3. And you can also concatenate tuples just like you can concatenate strings or lists using plus. So this tuple 1, 2 plus the tuple 3, 4, 5 will make the tuple containing 1, 2, 3, 4, 5. There it is. So now we come to the difference, or the most important difference between tuples and lists. And that is that lists are mutable. What that means is when you've defined a list, you can modify the elements inside that list or add and remove things from the list after you've created it. So I want to show an example of that. Here on line 1, we create a list called mylist, and that list consists of the numbers 1, 2, and 3. But on line 2, we modify the element in position 0 in mylist. So we're changing mylist so that its 0th element is not 1 and is instead 99. This is a perfectly correct thing to do in Python. It's fine. And line 3 is going to print out what mylist is. And you'll see when I run this that mylist has changed so that the element in position 0 is now 99 and not 1. On the other hand, with a tuple, you can't do that. Tuples are called immutable, which means you can't change a tuple after it's been assigned. So you can't change any of its elements, you can't delete any of its elements, and you can't add any elements. Let's see what happens when we try to do that. So on line 1, I'm recreating my tuple, which has got the elements 1, 2, and 3. And on line 2, we'll try to change the element in position 0. And this is going to give us an error. So when I run it, it tells me there is a type error. Tuple object does not support item assignment. That means that you can't change a particular item inside a tuple after you've created the tuple. This property is called immutability. Now, you can always reassign a variable name. So it's fine for me to create another thing called mytuple, but what I can't do is change the tuple that the name mytuple refers to. Now, mutable variables can be convenient. In fact, they're essential if you have some data that you want to represent in your program and you might need to modify or update that program, then you probably really do need a mutable type like a list to do that. But the problem with mutable types is that they can sometimes be a little bit confusing. So some things can happen with mutable variables which may seem confusing, which can't happen with immutable variables. Let me show you an example of this. So in this code cell, I'm defining two functions, and the intention that is that the input to both of these functions is some kind of list. So the first function here is called modify list, and its argument, its input, is referred to as lis. So all it does is change the 0th element of its input. And if you have a list A and you call modify list on A, then what will happen is that after that function call, the 0th element of A will have been changed. So in this function call, Python gets told where the list is in your computer memory, and that's what the argument list becomes. It becomes a reference to where this list is stored in your computer memory. And then on line 2, it looks up the 0th element in that list inside your computer memory, and it changes it. So when you call modify list on a variable you've got called A, then you will find after that function call that A is different to what it was before, always assuming it didn't have a 1 at position 0 to begin with. By contrast, if you call the next function, so this function called reassign list on a list A, then A will not be changed after the function call. The reason for that is that any assignment to a name inside a function definition, like this assignment here to the name list, creates a new local variable with that name. It does not modify any global variables which happen to have the same name. So really, this function reassign list actually forgets about what its input is on line 5. It just creates a new local variable called list, which doesn't overwrite any global variables, and it does nothing with that global variable. So reassign list is actually a completely useless function. It does nothing. Let's see this in action, just so we're convinced that this really does work. On lines 8 and 9 here, I create two lists called A and B, and both of them are lists of length 2 containing zeros. And on line 10, I call modify list. Remember, that's going to on A, and remember that will actually change A. A is going to be different after this function call. However, when I call reassign list B, that will not change B. In fact, it won't do anything at all. So line 12 is going to print out what A and B look like after those two function calls, and you'll be able to see that A is different. So when I run this there, you can see right here, that's A, and you can see that A has changed. It used to be 1, 0, like here, but now after the call to modify list, it's changed to 1, 0. This kind of thing can only happen because we have mutable variables, and so on line 2, we were actually able to modify those variables. So let's just recap, or not recap, but let me just tell you which Python types are mutable and which are mutable. So if you have a string or a numeric type, so an integer or a float, and a tuple of immutable objects, all those things are immutable variables in Python. So you can't modify a string after you've created it, and you can't modify a tuple of immutable objects, like, for example, a tuple of integers after you've created it. On the other hand, lists are mutable, and dictionaries, which we're going to see very soon, those things are also mutable. You can change them after you have created them. Okay, so to finish this video up, we're going to look at some further confusing behavior which can be caused by mutability. Actually, it's really a repeat of the confusing behavior we've just seen involving functions, but we're going to have a look at this in a slightly different concept. So let me go back to my notebook here. I'm going to go right to the end here, and let's just zoom in a bit more so we can see it. Okay, so look at this code cell at the bottom here, and forget about line 1. That's just some magic which is going to make a nice illustration of this concept appear. But let's think about what these lines of code are in this code cell at the bottom. On line 3, we create a list called A, and its elements are the 3 strings, the string just with A in it, the string with B, and the string with C. On line 4, we create a new variable called B, and we define B to be A. And what that means is that B and the A both refer to the same bit of your computer's memory in which this list is stored. Then finally, on line B, we change the 0th element of B. We change the element of B at index 0. So we change it from the string A to the number 99. And then we print out at the end A. And the big question is, what is A going to be? In fact, what we're going to find here is that A has changed. So even though we modified B, A has changed. And the reason for that is that B and A, the names B and A, both point towards the same bit of your computer's memory. So I'm going to run this to show you a visual illustration of what's going on here. So when I run it, here we go. So let's look at the right here where it says global frame. Don't worry about what global frame means, but we're going to step through the lines of code one by one, and you're going to see an illustration of what's happening inside your computer when it runs lines 3, 4, 5, and 6 of this code cell. So we begin here on line 3. We create this variable called A, and the name A then points to this list somewhere in your computer's memory. That list has 3 positions, so position 0, 1, and 2. And position 0 points to a string which contains A. Position 1 points to a string B, and position 2 points to a string C. Okay, let's take the next step. So we're going to go on to line 4. What happens in line 4 is we get this new variable whose name is A, and it points to exactly the same place that A points to. So both the name A and both the name B point to the same bit of your computer's memory, which is a list of length 3 containing the strings A, B, and C. Okay, one more step then. So line 5, what happens in line 5 is we we change the thing which is at index 0 in the list pointed to by B. So there we go. You can see there that this has now become 99. So our list contains 99 and B and C. And again, still A and B are pointing to the same place in memory. So that on line 6, when I print out A, what Python will do is look for this list and then print out the things in it, which are going to be 99 B and C. So even though on the face of it, it seemed like we changed just this list B, we will actually have changed both of them. So that you can actually see what happens when I do this, I'm going to get rid of this line at the start and run it again, and you can see it really does happen here. So when I print out A on that last line, line 4, we now have 99 B, C. This is another important thing to think about. If you have strange behavior happening with lists, it's probably something like this going on.